All right, in this example, we have 100 students where X, whether they liked certain candy flavors. It was found that 50 liked lemon, 42 liked mango, and 15 liked both flavors. What's the probability that a randomly selected student liked either flavor, like either lemon or mango, but not both? Okay, so I'd like to do these problems using a Venn diagram. So let's look at a Venn diagram for the first example. Okay, so there's my universal set. In this case, it's the sample space. Here is my one event. Oops. Okay, so one circle is the event a student liked lemon. And the second event is they liked mango. Okay, so to answer this question here, the first one liked neither flavor. That means essentially we are interested in neither flavor. Means they didn't like lemon or mango. Okay, so that means we're looking basically for this portion of the Venn diagram. In other words, the probability of the outside. Okay, so in order to find that, we can use the complement idea. And the complement idea says the following: the probability that a student liked neither flavor is equal to the probability of, it's equal to, by complement rule, 1 minus the probability they liked lemon or mango. Okay, and so that is an OR statement. And so I'm going to go ahead and calculate that, but I'm going to write it inside some parentheses here because this is a union of two events, and we know that it's the probability that they liked lemon plus the probability they liked mango, and then plus the minus the probability they liked both, right, where the overlap happens. Okay, so then of course if they liked lemon, we know how many people liked lemon. There was 50 out of 100 who liked lemon. And there was 42 who liked mango out of 100, and then minus those who liked both. Okay, which we're given that is 15 over 100. Okay, so let's find what that is. All right, so let me take a calculator. From my calculations, I get 77 over 100. Okay, and then we need to subtract that probability there. So that's 100 over 100 minus 77 over 100. And let's figure out what that is. So we have 100 minus 77 over 100. And we see we have 23 over 100, which is already a reduced fraction, and so the probability they liked neither flavor is 23 over 100, or 0.23 as a decimal. All right, likewise. Okay, so using the Venn diagram, we can find the probability that they liked either lemon or mango, but not both. So using our picture here, we could see that it's the portion here that liked lemon but not mango, and this portion here that liked mango but not lemon. All right, so one way to get this is play around with the numbers. However, I noticed that one way we get the complement rule again, and basically complement would be those who like both lemon and mango, and those who like neither. So we could use that idea again if you want. That's one way of doing it. And so if I do that, then that means the probability that they liked mango or lemon and mango or mango, but not both, can be found by going 1 minus the probability that they liked both or neither, which is the portion. The both part is the part in the middle, right? That where they overlap, and the part where they like neither is the stuff on the outside. Okay, and we know those two probabilities using in there. They're mutually exclusive, so we know that's the same thing as saying the probability of both plus the probability of neither. Okay, so then 1 minus, well, that they probability like both, we know there was 15 people who like both lemon and mango over 100, plus the probability that they like neither, which we know was 23 over 100. And so that's equal to 1 minus, well, 15 plus 23 gives us 38 over 100. And then 1 minus 38 over 100 would be 62 over 100. And let's just reduce that fraction. 62 over 100. Clearly a 2 goes in. So 2, so that would give us 31 over 50. And that's how you do that example.